Starting with permutations. Mary decides to flip a coin and record the outcomes. Every 3 flips, she records what happened. In the table below, this is what she's recorded so far. How are these 3 outcomes similar? Notice they all have 2 heads and 1 tails. How are they different? Well, they're in different orders, aren't they? Which outcome describes a coin flip that resulted in heads the first flip, heads the second flip, and tails the third flip? Well, there's only one of them. Outcome number 3. It's the only one. Next question, did the order matter when determining that answer? Yes, because it was asked in a specific order. Which outcome might describe a coin flip that resulted in heads twice and tails once? Wasn't that all 3 of them? Did order matter? No, we just wanted 2 heads and 1 tails. Can the 3 outcomes be considered the same if the order of the elements matters? Okay, if the order matters, those were 3 totally different outcomes. What if the order doesn't matter? Well, then they were all the same, 2 heads and 1 tails. Factorials. Let's say you have 6 Beanie Babies on your bed. How many ways can you put them in order? Well, there are 6 of them. So any of the 6 could be first. And then next would have to be one of the 5 remaining, and then the 4, and so on. So if we use the counting principle, that would be 6 times 5 times 4 times 3 times 2 times 1, which is 720. That's a lot of multiplying. There's a faster way. It's called a factorial. French mathematicians Aboust and Cramp both generated the idea of the factorial. It's a simpler way to show the product of the numbers from 1 to the number you want. It's represented with an exclamation point. So remember the 6 Beanie Babies? 6 times 5 times 4 times 3 times 2 times 1 can be represented by 6 factorial. So it's not just like you're going 6, it's 6 factorial, which is the product of all of those numbers. There's a button for this on your calculator. So if you go to math, type in the 4 first, type math, arrow over to the PRB tab, which represents probability. The 4th choice down is factorial. So you can arrow to 4 or you can just hit 4 and your screen would show 4 exclamation point, 4 factorial, and you get the answer. Permutations. An ordered arrangement of items is called a permutation. So some of the words you look for: arrangement, order, list, schedule. I remember permutation starts with a P, and so does pageant. Does the order matter in a pageant? Absolutely. If you're first runner-up, you're not the winner. So permutations, order matters. So consider our flipping coins. When we specified what the first, second, and third flip should be, order mattered, so it was a permutation. The Environmental Club is electing a president and a vice president and a treasurer. How many different ways can the officers be chosen from the 10 members who are running for office? Well, any of the 10 can be president, so first spot has 10 choices. Now there's 9 left for the VP, and there's 8 people left for the treasurer's position. So 10 times 9 times 8. Will this answer be 8 factorial? Well, no, it's not the same thing. But it would be 10 times 9 times 8. So 720 different ways. That's not a lot of multiplying, but some of these do end up with longer multiplications, and there is a way to do that that's shorter. What if out of the 10 people running for office, there would be 8 positions available? 10 times 9, 8, 7, 6, 5, 4, 3. That's a lot. It's not 10 factorial, but we have a formula for that. It's the number of total, which is the 10 factorial, divided by the total minus how many we want. So in this case, that would be 10 minus 8. So you can use your calculator. Alpha y equals 10 math probability 4, and on your denominator, parentheses, 10 minus 8, parentheses, math probability 4, and you get 1,814,400 ways to fill those 8 positions. Will this work with the original problem? 10 members, 3 positions? Well, let's see. 10 factorial over 10 minus 3 factorial, 720. So it does work. Isn't that better than multiplying it all out one number at a time? Yes, it is. No? There's a button for permutations too. So permutations, different arrangement of the same 3 members is a different result than order matters. So NPR. So the first thing we're going to enter in our calculator is the total number of things. Then we're going to go to the probability screen and pick the permutations button. And the second number is the number of chosen things. So N is always bigger than R. And your calculator does this formula for you. So if we have 10 items, 10 total members, we're choosing 3 for a specific office, 10P3. So on your calculator, you type in the 10, math, scroll over to PRB, and it's number 2, probability. And then you put the 3 in afterwards. Let's try this. An ice cream shop sells sundaes, 2 layers, 4 layers, and 5 layers of flavors. The shop carries 65 flavors. How many different 4-layer sundaes can you make if you do not repeat any flavors? So order is going to matter because we want them in different layers. So that would be a 65P4. So you push the buttons on your calculator, 65, math probability, P, and then 4. 16 million different sundaes. Why is this a permutation? Only one flavor can be first because the order of the layers mattered. Which type of sundae would give you the greatest number of choices? Well, let's see. Use your calculator. 65P2, 65P4, check out 65P5. 5 layers has the greatest number of choices. Combinations, very similar, but in combinations, the order doesn't matter. An unordered collection. So some keywords are group, committee, sample. So remember for permutations, I remember pageant. For combinations, I remember committee. If we're just picking a committee of people, the order doesn't matter. No one's in first place, no one's in second place. It's just a group. So go back to flipping the coin. If we did not specify the order and we just got 2 heads and 1 tail, all of those counted as 1 possibility. You have a new lock on your phone that uses a 2-letter code out of A, B, C, D, E with no repeats. How many combinations are there if order doesn't matter? Well, there's 5 choices and I want to pick 2. So there's all the possibilities there. Well, remember, order didn't matter. So let's take out the repeats. So AB and BA are the same thing. AE and EA are the same thing. So now there's only 10. 5 times 4 times 3 times 2 times 1 is the total number of choices, but you only want 2 of them. So divide these out and take out the 3 extra choices. That leaves 5 times 4. If you stop here, you have a permutation. Now remove the choice order because AB and BA were the same thing, so we divided by 2. That might sound confusing. So here's how we're going to do it. Your English class requires you to choose 4 books to read over summer break from a list of 12. How many different ways are there in which to choose the books? Notice it didn't matter what order we read them in. So this was a combination. There's the formula for combination using factorials. And as you can imagine, there's also a button for this on the calculator. NCR. So you go to your math probability and you pick the C instead of the P. And your calculator will do that formula for you. So on this one, it was 12, C4, 12 books. We're going to choose 4 of them. And it didn't matter what order we chose them in. So there's the probability menu, and you pick the NCR, and then you type your second number, how many we wanted to choose. The service club has 20 freshmen, and 7 are to be chosen to be on a cleanup crew. Does order matter? No. So it is 20C7. And you push those buttons on your calculator. 20, math probability, C, and then the number 7. And you get your answer. Why is this a combination? Because it's just a group. Order didn't matter. The club also has 18 sophomores. If 7 sophomores are chosen to join the 7 freshmen, how many ways can the crew be made now? Well, we already know there's 77,520 ways that I can choose the freshmen. Well, let's find out how many ways I can choose the sophomores. So the sophomores, there were 18, and we're choosing 7. So we're going to do the multiplication, 20C7 times 18C7, and that's a lot of combos. Because order didn't matter. Permutation or combination, and then solve. So there are a lot of these. I'm going to scroll through them, and if you'd like to pause and work it out on your own and check your answer, that'd be a great idea. The number of ways you can choose a group of 3 puppies from the animal shelter when there are 20 breeds to choose from. Combination. And pause the video if you don't want to see the answer yet and you want to solve 20C3. The number of 7-digit phone numbers that can be made using the digits 0 through 9. There's 10 digits there. We want 7 of them. Does the order of our number matter? I think so. Pause the video if you don't want to see the answer yet. 10C7. The number of ways you could award first, second, and third place medals. Does order matter? Yes. There are 52 students. There are 3 medals. Put it in your calculator. Pause if you don't want to see the answer yet. The number of ways a committee of 3 could be chosen. That's a C for committee. Put the values in your calculator. Pause if you don't want to see the answer yet. The number of ways a president, vice president, and treasurer could be chosen. Does the order matter? Yes. 20P3. A standard deck of cards has 52 playing cards. How many different 5-hand cards are possible? Does order matter? Order does not matter. 52C5. If there are 13 people on a softball team, how many ways can we choose 10 players to take the field? Does order matter? It doesn't say, so we're going to go with a combination. 13C10. There are 5 people on a bowling team. How many ways can you choose your captain and manager? Does order matter? Yes. 5P2. A pizza parlor has a special on 3-topping pizzas. How many ways can it be ordered? If they have 8 toppings to choose from, an order doesn't matter. So that means it's a combination. And you're going to do 8C3 because we're picking 3 of those 8 toppings. A pizza shop offers 12 wing flavors. How many different 3-flavor wing plates can be formed if the cook places them from hottest to mildest on the plate? So without that last if, order didn't matter. But as soon as we started putting them in specific places, order matters. 12 wing flavors, 3 flavors are chosen. So 12, we picked 3. Find the number of possible committees of 3 people from a class of 30. Does order matter? It's a committee. 30C3. There are 11 seniors on the football team. There will be 4 captains. How many ways can seniors be chosen as captains? Did order matter? Nope. 11C4. Your English teacher has asked you to select 3 novels from a list of 10 to read as an independent project. In how many ways can you choose which books to read? Does order matter? It does not. 10C3. You download 11 songs on your iPod. If you select random shuffle, How many different orders of the 11 songs can be played? Did order matter? Yes, it did. So this one's 11P11. That's a lot. Just a few more. 14 games. Athletes are competing in the X Games. How many possible ways can they get gold, silver, and bronze? Does order matter? Yes. There are 4 awards. So 14P4. There are 30 students in the classroom. 6 of them are able to be chosen to clean up the room. How many different ways are there to choose the 6 students to clean the room? Did order matter? It did not. 30C6. There are 11 people on a baseball team. How many different ways can pitcher and catcher be chosen? Did order matter? Yes. 11P2. How many different numbers can be made using any 3 digits from this number? Does order matter? Yes, because they're different numbers. How many different ways can you arrange 10 CDs on a shelf? Does order matter? Yes. A professional basketball team has 12 members, but only 5 can play at one time. How many different groups of players can be on the court? Notice it just said groups. Did order matter? No. So 12C5. Megan has 4 different skirts, 8 different blouses to choose from. How many outfits are possible if she chooses 1 skirt and 1 blouse? So did the order matter? It does not say, so we're assuming every skirt matches every blouse. So we're choosing 1 skirt, 4C1, and we're choosing 1 blouse, 8C1, and we multiply the result together to get our answer. Now you're going to practice your permutations and combinations.